So hi, this is Priya from Aarna Networks. Thank you. I thank you all of you for taking time out here and being here today. We are back with our knowledge sharing session. Well, we all know machine learning will play a big role in the 5G network as a network optimization and automated service assurance. As a part of the AMCOP Aarna stream effort, we are implementing both NWDAF and non-RTRIC functions. Our partners, Predera offers a leading MLOps product called AIQ. Jointly, we can address the requirement of NWDAF and non-RTRIC. Well, we would love to hear all your queries, but we'll request you to keep it for the end of the Q&A session. And not to worry, in case you miss anything, we will be sending out on-demand recording. Let's not delay and start the session. So our presenter for our speakers for today, Mr. Shriram Rupana Gunta, co-founder for Aarna Networks, Vamshi Ambati, founder and CEO of Predera, and Sandeep is a senior technologist at Aarna Networks. Thank you and welcome all of you. Shriram, will you take it from here?
Sure.
Yeah.
Can you stop sharing?
Yes.
All right. Hi, everyone. So I will not take much time. I will just give a brief introduction to AMCOP because Sandeep's presentation will have a lot more detail. So for those of you who might have missed our past presentations, so essentially what AMCOP does is three things. So one is intent-based orchestration. The second is a lifecycle management, and third is a real-time closed-loop automation. And that's what we also call as Aarna Analytics. And that's the part that we will be zooming in today for today's session. And also let me give a brief introduction about the AMCOP modules. So there are multiple modules, some of them open source, which are all upstreamed, and some which are proprietary value adds. So again, I will not go into the detail of all of the modules for today. There are some past sessions that we can point you to in case you need any of the details. But essentially for today's session, what we'll be focusing on is what I'm showing on the rightmost side, which is the Aarna Analytics platform. And this again uses a few open source projects from one app called DCAE. And it also has other interfaces for integrating the AML apps and so on. And that's the part that Sandeep is going to cover today. There are two features that we are implementing in as part of AAP, which are non-real-time RIC and NWDAF. So this is essentially for the 5G RAN and the core functions. And the next presentation from Sandeep will have more details. So I will not go into any detail here. So that's essentially the introduction that I wanted to share about us. And then, so probably I'll just turn it over to Vamshi to give an introduction about Predera. Yeah, Vamshi, you want to go ahead?
Yeah, sure. I'll just share my screen right here. You guys see the screen?
Yes, Vamshi.
Okay, perfect. Yeah, good morning or good evening, everyone. Vamshi Ambati, founder and CEO of Predera. So we are pretty excited about this opportunity of plugging into the 5G ecosystem and working with the AMCOP platform and enabling the machine learning and data applications on top of it. I mean, both we can help in the network optimization side of things, as well as downstream if you're building any more data applications. I think you should definitely consider Predera AIQ as a platform of choice. So, we are a Bay Area startup with R&D center in Hyderabad, which is run by my co-founder Nazir Hussain here. We are a small team of about 30 plus engineers that are putting this together, and we're being advised by a good set of folks, both from industry and academia. So when you're considering building an ML application, that is, or a machine learning model, and you're trying to plug that into AMCOP, couple of things to consider are, one, there is a training workflow where you're putting together a model, and that basically starts with pre-processing pre-processing phase where you're bringing in your ground truth data and the raw data and putting that together as a training and test set. So you're building a model on the training data and testing and validating on your test sets. And as part of this, there's several functions that you might be working through, which is like what is called feature extraction, scaling, feature selection, or any of the sampling and dimensionality reduction, etc., as the use case demands. So after that, you're essentially in the learning phase where you're building a model, which sort of also involves a bunch of steps where you're trying out different models, working through which one is a better fit for your data sets, doing some hyperparameter optimization, etc., and arriving at an algorithm that, or arriving at an algorithm and the subsequent model that is trained on the data sets using the right validation setup and so on. So once you have the model, it's not a one-time effort building an ML model. You're sort of iterating over that with new labels or new data sets. And once you have evaluation, you're sort of looking at that over a period of time to understand if this model is robust enough for your use case, and sort of iterating over that. So this whole exercise of sort of building and training a module, training a model and testing that, and going back to whether this would be the right fit, etc. So this is really a tedious, time-consuming process that data scientists usually start off with sort of a manual approach, trying to arrive at a first cut model, and then start thinking about tools and frameworks to help them. So AIQ essentially falls in this space, and it's a full life cycle machine learning operations solution for you. So what that means is we help both during the training phase and putting together the model, and the deployment phase, and sort of also post-production phase, something that I'll talk about next. So if you just make sure you can see the whole thing. So if you're looking at the product lifecycle, so what I just showed you is the development lifecycle, but the product lifecycle has, the data scientist using some tools to train the models, which is the training phase that I talked about before. And then you sort of hand it off over to someone like a machine learning engineer who's taking that model and putting together a CI/CD pipeline. And a pipeline here is different from the typical CI/CD pipeline that you're used to in software engineering, because in ML there are three things that could change. One is the data could change. So there might be new data that is continuously added. So that means such data should trigger a change in the actual model also. Two, code could change, like the way you treat and modify your data sets, etc., or some pre-processing functions that might be changed to suit your business logic, that could change. Or three, the algorithms and the subsequent parameters associated with those could change. So when those when you see such changes, then you need to have a robust CI/CD pipeline that goes all the way through from those changes into the models or the new models that might come out of those changes. Once you have a pipeline like that, you have the final step, which is how do you now integrate that downstream into your applications. And so here, typically you would hand it off to a DevOps or a software engineer who's starting to consume those applications. And for them, it's really as sort of a library or a module or an API of sorts. And once you have that, you're essentially in the predictions phase, where the user is essentially benefiting from the predictions of the application, and that whole cycle, when you see that there is a drop of accuracy, etc., then you again go back and retrain. So the data scientist is always tracking how well his models are performing. So this whole so it's not just building the model that enables a good data product, but you have to have this whole entire full life cycle approach of how do you start with your simple experiments, how do you then publish a model and hand it off, and then how do you have a CI/CD pipeline that enables or that works through any changes in all the three that I mentioned, and then having a simple way for application developers to sort of integrate into these applications. So AIQ is essentially, so I'm going to skip that because I think these are challenges that I just talked about. But AIQ is essentially a 3-module solution. So one, you have a workbench where data scientists can log in and build applications, build models. Then you have a deploy module, which is the CI/CD pipeline that I talked about, which simplifies taking these pipelines, both the training pipeline as well as the scoring pipeline, and then putting together a robust deployment framework. And then we also have a monitoring framework, which looks at how the model is performing and when an intervention is required. So if the predictions are not working up to the mark, then the data scientist is called in to sort of, or alerted so that he can make changes accordingly, and then that cycle continues. And we operate it on top of Kubernetes, so sort of agnostic to any platform, any cloud of choice. And so it's a very simple integration with that. When we heard about the AMCOP approach, it seemed like a no-brainer that we could actually work as a drop-in module for all the machine learning sort of work related to the 5G use cases. So I will. I'm happy to take questions towards the end, but I thought I'll just show you quickly, how the product looks like. And this product is also available online for you to sign up and build your first models. It's fairly straightforward. I'll just walk you through a few screens to show you how this works. So first, when you sign up, you sort of see this screen. So when you first sign up, you may not have any projects or a machine learning project here that you could work through, but we created a very simple data set and simple module. So you might see this churn application, which sort of comes as a playground for everyone to work with. So you'll see all the projects that you're working with in a particular organization and that you have access to. So for example, here you see a bunch of people collaborating on this particular healthcare project. So or you could have just you working on a particular project. This is the sample project that we give it along with this. So this is the sort of the first entry dashboard where you see all the projects that you have access to, and then you can go in and create what you call is data science development environment. And for the most part, data scientists usually like to work with Jupyter notebooks, but necessarily like sort of with all the right dependencies that they might need to be productive in that space. So we have a very one-click way of spinning up a notebook environment, and you can choose and see what's suitable for your use case, whether it's a TensorFlow backed notebook server, or it's an R, or simple scikit, or any other. I think we have 3 or 4 more configurations. So you can kick off a notebook server with all the dependencies, so you don't have to go through the whole installation and infrastructure configuration exercise, etc. And you can also choose the size of it. If you have a huge data set, you can sort of run this on GPUs. If you have a much and you want a faster training, then you can use the GPU side of things, or you could just have a high RAM, high storage sort of CPU backed as well. So you can pick and configure those and spin off the notebook server. And one of the things that you get out of the box is this whole version control and experiment logging of your models. So as I mentioned early on, data science is sort of this iterative effort working through different algorithms, libraries, configurations, etc., to arrive at the right model. So as part of it, you might end up building hundreds of experiments to really arrive at what is the right fit for your data set. And all those experiments get logged automatically without any additional effort from your side. So this is almost like acting as a Git for all your experiments and tracking all your performances across these experiments. So you can click and compare 2 experiments, or like I think about 5 or 6 experiments at a single go, and pick the one that actually works for you. So once you take an experiment, then also in the experiment, you can also for each experiment, you can also look at how well they're performing. Sort of we capture all the performance metrics. We also capture what are the top features that contribute to the performance of the model. and you can visualize some of these as well. So we have different visualizations as per the algorithm types, because you have supervised classification kind of algorithms, or you also have your regression sort of algorithms or unsupervised algorithms where you don't have labeled data, etc. So you have different visualization screens based on the algorithm type. But all of this gets captured as a model or an experiment, and you get to see all of that under that tab. So once you like an experiment, you can sort of click a single, I don't think I have that here, but you can sort of click and deploy. You can select the experiment and click and say deploy this, and all of that is one click, since all the dependencies are captured up front. So it's fairly easy to just convert that into a simple API. So at this point, you can integrate at the API level, or we also have planned an integration for AMCOP, where you can export this model directly into the AMCOP setup and sort of go to production in that environment as well. So we would handle all the training on large-scale data sets using our infrastructure and build the model and sort of drop the model back into the AMCOP environment or wherever this needs to go. We have several integrations already where you can publish these models to any cloud, sort of deploy these models on AWS or Azure, etc. Or we have our own deployment engine, like you see here, where you convert these modules and these models into API endpoints that you can ping. And so each endpoint we also have, both internal and external. You can sort of test these right there from the online. Also track the resource consumption and resource usage. If you have a high traffic environment, then this automatically scales by adding more pods to it. And you can also track, if any errors, etc. So all the logs and everything is logged for you as well. So lastly, I think the feature that we also have is being able to visually compose these into one pipeline or so. So this is a visual workflow interface where you can connect to data sets. This could be the AMCOP data lake, or it could also be an S3 bucket or a database, etc. So pull that, add all your data processing scripts, and then sort of trigger a distributed training pipeline, run a parameter tuning, etc. So all of this can then be scheduled to run on a daily basis, or it can also be conditional, meaning if there is a drop in accuracy, or if there is a drop or change in data distributions, then this workflow gets triggered again and sort of creates your new model that is more suitable for your data sets and incorporates all the changes. So this is sort of the last feature that we am going to talk about today, where you have workflows that are both training or testing workflows or things that you can compose here, and we can then rebuild the model and drop it back into AMCOP as needed. So just putting all of that together, but we have a rich support for a variety of ML libraries that at least I think about 80% of data scientists that when we ran our surveys, we sort of saw that they are within these frameworks of choice, like scikit-learn, Keras, or PyTorch from Facebook, or TensorFlow from Google, Spark from the Databricks folks, H2O, R, etc. So we have full support baked into this platform for all these libraries of choice. Right, so I'm going to stop at that today, and I'll encourage you to sign up. It's a free sign up. You can start playing with this already and sort of see the benefit of a full cycle ML platform, which can take a data scientist through building modules, building models using any of these libraries, then deploying it, as well as tracking post-deployment, the performance, etc. All right, so with this, I'll hand back to Sandeep. Thank you, guys.
Thanks, Vamshi. Let me share. So hi everyone. So I will start with a brief introduction of the NWDAF and the near real-time RIC, followed by the requirement for an MLOps kind of platform in order to address the complete NWDAF and near real-time, non-real-time RIC use case. And then towards the end, we'll present the end-to-end picture in the context of AMCOP. So yeah, so with this introduction, let's start with the NWDAF. So NWDAF is the analytics function for the 5G core, and it provides the analytics info to other network functions, application functions, and the OEM platform in the 5G core. And it provides standardized interfaces for both data collection as well as providing the analytics information. It could be either over subscription, or it can be addressed through a request. A network function can request for one-time analytics info from the NWDAF. NWDAF is essentially a network function, and as I already said, it basically exposes the 3GPP standard specified APIs. And each NWDAF can basically address a specific analytics use case. And these use cases and services are also specified by the 3GPP. And there can be multiple instances of NWDAF deployed in the 5G core. And each NWDAF is identified through NFID and the analytics ID along with that. And like every other 5G core network function, the NWDAF basically registers itself with the NRF in the 5G core. And that is how it makes itself available to other network functions, which can basically then discover this NWDAF through the analytics ID that it possesses. And the information that the NWDAF provides. So there are two kinds of information. So one is basically the statistics, and it can also provide the predictions. And for predictions, primarily it can make use of the ML models, which could be embedded into this NWDAF. And these ML models can address specific use cases. And in order to enable itself to provide the analytics information, the NWDAF will require the data from the 5G core. And for that, basically, it fetches the data from the application functions and network functions in order to get the UE related data. And of course, the OEM as well for getting the global network function data. So this is at a high level what the NWDAF is. NWDAF use cases. So on the left hand side of this slide, what we see is the NWDAF supported services as of release 16. So these are the services which are specified by 3GPP. And what that means is 3GPP specifies the use cases for each service, the input data that the NWDAF expects, and the output that it produces. So to name them, so basically there are services for slice, load level related analytics, observed service experience related analytics, network function load analytics, network performance analytics, UE related analytics. So these are the services that are specified by 3GPP. And using these services, there are different kind of use cases that the NWDAF can address. So on this slide, we see that. So NWDAF, now we can call that NWDAF is AI/ML enabled NWDAF. And it can address various use cases to basically enhance the performance of the 5G core in the 5G core clusters, take care of the service assurance of the 5G core applications, and also customize the UE mobility management, assist the PCF assist the PCF in dynamically managing the policies and changing the routing information in the SMF, or basically selecting the appropriate UPF dynamically for the 5G service. And also, I mean, in case of slicing, it can enable the NSSF of the 5G core to predict and allocate the resources proactively so that there is no service disruption. And also the fraud prediction and prevention of the security attacks. So these are the kind of use cases. There are many more use cases. These are just the examples which can be addressed by using the NWDAF. After NWDAF, now we are looking at the non-real-time RIC. So non-real-time RIC is a component in the SMO framework of the ORAN, specified by the ORAN SC. And non-RTRIC is more of a platform, and it serves the similar purpose as the NWDAF. It basically enhances the functionality of the RAN through the near real-time RIC in the remote clusters. And how it does is, in the real time, it basically provides the policies, enhanced policies, and the enrichment information for the functionality of the RAN through the near real-time RIC. And non-RTRIC is more of an extensible platform, and that is possible through the RApps. So RApps are the applications, modular applications in the non-RTRIC, and they can serve different purpose, and we can keep adding the RApps in non-RTRIC based on specific use cases. So in that sense, it is extensible. Along with RApps, the non-RTRIC contains other services, and those services are basically the A1 policy functions, enrichment information functions, and the A1 termination, basically. So what non-RTRIC does is it provides the enrichment information and the latest A1 policies over the A1 interface to the near real-time RIC. And for that purpose, these are the different services that it has. And non-RTRIC also specifies the use of AI/ML, and they introduced this concept of AI/ML functions also. And through these functions, basically, these functions are then responsible for making inferencing of the ML models, and then making sure that these ML models are working efficiently by continuously monitoring the scores of the ML models. And whenever required, these ML functions can interface with an external AI/ML server and trigger the offline training of these models if required, if the score goes down, or because throughout the life cycle of the RApps, they might need to get retrained with the latest data in order to keep working efficiently. So yeah, at a high level, this is what the non-real-time RIC is. And these are the use cases that the non-real-time use and non-real-time RIC can address. And I actually spoke about these. So the first one is user level policies. So non-real-time RIC can basically influence the RAN behavior by providing the latest and greatest policies. And the XApps in the real-time RIC then will basically work based on these policies and enhance the service experience of the users or user groups, UEs or UE groups, to say. And then non-real-time RIC, as I said, provides enrichment information over the A1 interface also. And the RAN can use this enrichment information in order to enhance the functionality. And another use case is the self-organizing networks. So based on the information from the non-real-time RIC, the RAN in the basically we can dynamically and based on the triggers, we can orchestrate or spin up new resources to make sure that there is no disruption in the service. So this is about the use cases of non-real-time RIC. So on this slide, basically it's a summary of the previous slices, what the differences are in the NWDAF and the non-RTRIC. So NWDAF is more of a network function, and it provides the analytics info to the 5G core service, 5G core network functions, application functions. And the non-real-time RIC is more of a platform, and it basically helps the near real-time RIC and the RAN to enhance the functionality and take care of and make sure that there is no service disruption. And yeah, so basically, yeah, I mean, making sure that the RAN works uninterrupted. And with these differences, and what do we see? What is common between the? I mean, so we see this trend, and there is a commonality in terms of requirements from the NWDAF and the non-RTRIC, and that is basically both. In order to address both use cases, we need to deploy the NWDAF with ML model, and in case of non-RTRIC, the RApps are the applications with ML models. And in order to maintain the life cycle of ML model, we need MLOps kind of platform. And so, yeah, so basically this lays the requirement of an MLOps kind of platform on top of the AMCOP. And this is what we talk about in this slide. So the requirement and solution. So AMCOP is capable of orchestration of network services. And along with that, AMCOP is capable of orchestrating NWDAF in the 5G core. And AMCOP incorporates the SDNR from ONAP. So in that sense, it has the SMO functionality and the non-real-time RIC functionality. AMCOP can perform the job of ML model or ML service inferencing, but AMCOP does not have the capability of training these models and yeah, basically managing the life cycle of the model itself, the machine learning model itself. So in order to address that gap, we plan to basically partner with Predera, and that is what Shriram said in the introduction, and Vamshi gave an overview of the product, and he also touched upon the points on how the AMCOP can interface with their MLOps infrastructure. So with this, we can move on to the next slide, which is about. So this slide at a high level shows the end-to-end picture, and what we see on this screen is above AMCOP sits the layer which has the MLOps platform, and if you see the flow 1, 2, 3 is pretty much what Vamshi described. So on the MLOps platform, we can upload the machine learning models, and then create the pipelines which can transform the data read from the data lake, and then train these models. And eventually these trained models should land into a ML catalog. And for that, in this proposal, we plan to leverage the work that is done in AMCOP and AMCOP work that is done in ONAP. And there it is about interfacing with the ACUMOS platform. And the ACUMOS platform will serve the machine learning service catalog to the AMCOP platform. And ACUMOS has one functionality which is basically it can convert the machine learning models to microservices. And microservices are what the AMCOP will basically orchestrate. And after the 3, below box shows the AMCOP, where wherein we plan to service will interface with ACUMOS, and it will basically consume the machine learning model services. So AMCOP has a GUI, and AMCOP platform and during the design we can specify the machine learning microservice which is in ACUMOS, and during the runtime phase we can basically instantiate this service, and as a result what we will get is NWDAF, the ML enabled NWDAF getting deployed in the target 5G core cluster. And then of course the NWDAF machine learning service can be one container in a pod, for example, but then there is a layer above it which basically exposes the 3GPP specified interfaces NRF and make it available to the other network functions in the 5G core, and then basically providing the analytics info subscriptions to other network functions, for example. So this is at a high level how the pieces can be joined together. So on this slide, we see the end-to-end NWDAF in the context of the AMCOP. And so on the top, we see the MLOps MLOps infrastructure layer, and the 1, 2, 3 on this slide is same as what I already explained. So in this, and what is happening is in the AMCOP we have this model inferencing microservice, and as I explained, it will deploy the NWDAF, the machine learning microservice enabled NWDAF in the target cluster, and it registers itself with NRF and it is ready for the service. And AMCOP has the OAM microservice, OAM platform getting implemented too. And the OAM will basically provide the required data to the NWDAF in cases where the NWDAF requires the metrics related to the infrastructure, for example. And on this slide, we see that for collecting those kind of metrics, we can deploy Prometheus in the target cluster. And Prometheus, with its service discovery feature, can discover the node related metrics, or it can push these metrics to a remote database, and then that data can land basically that remote database can act as the data lake for the MLOps infra, and we can trigger the pipelines which can transform this data and, for example, model the CPU load prediction machine learning models in the Predera MLOps infra. And then this, I mean, after the training, this model goes through the whole life cycle and then gets deployed in the target cluster. And now the NWDAF can basically predict the CPU load of the other network functions which have subscribed for this kind of information. Yeah, so at high level, this is the end-to-end flow of how NWDAF can be implemented and deployed. This is similar to the previous RIC, but this is in context of the non-real-time RIC. And over here, we see that we are through the model inferencing microservice, what we are deploying are the RApps, and then these RApps will basically provide the policies, for example, provided that, I mean, we give the required information or required parameters to this RApp, and they can come up with the traffic steering policy, for example, which will be deployed in the real-time RIC. And yeah, so the does this, collecting the data over the O1 interface from the RAN in the target clusters, from the CUDU, for example. And then this data is pushed to the data lake from the AMCOP, and we can train for example, this RAP model based on this data that we are uploading to the data lake. And similarly, over here also, Prometheus can be used in order to train the infrastructure related or CPU memory related machine learning models. Yeah, so basically now this is how the non-real-time RIC can be implemented along with the machine learning MLOps infra in the context of AMCOP, and yeah, just connecting all the pieces together in order to make it functional and address the use cases. Okay, yeah. So that's all I had. Thanks. Any questions?
Thank you, Sandeep. We will just give few seconds so that if anyone has questions, they can ask. There are a few questions which I'm getting on chat also, so our panelists are helping them. Yeah, audiences, you can ask the questions. Okay, so here is one question that I have got. How do you deal with large scale data and workloads?
Is this for me or
Vamsi, I think
Vamsi?
you can.
Yeah, I can take this.
Yeah.
So basically, I think if your workloads have huge data sets, like just Sandeep just showed, that you can drop this into the data lake that is set up, or you have it either in some place called S3, etc., or some kind of a file system, then we can pull from there. During training phase, if you expect a lot of data that this model needs to be built on, like an anomaly detection model or a fraud detection model that's looking back multiple years, this or where we can start this off on high RAM sort of setup, that's one way to deal with large scale data. And if your algorithm is actually requires such footprints, then you start off with a high RAM sort of scenario. The other being like, if you just have like deep learning algorithms which can be parallelized massively on GPUs, so you'd also use some sort of a GPU in your training setup. That's what some people using deep learning would prefer and go with. So we have sort of configurations for those as well, and we definitely support both GPU-based distributed training as well as CPU-based. So you can pick one or the other for your use case.
Okay. Thanks, Vamsi. Okay. So the next question is, can customers use latest deep learning algorithms and what libraries are supported?
Thanks. So I guess that's me too. So yeah, like I think I was showing on the slide as well. So we have support for TensorFlow based models. So you could use algorithms coming from there straight up. Or we have support for PyTorch, Keras. These are like the three major deep learning libraries that people use when training some of these deep learning enabled models. So we have full support for those.
Okay. I think it has come to all of us. Okay, I think Shriram is also answering. Okay. So what is the data retention policy for MLOps engine? That's for you, Vamsi. Yeah.
Yeah, so I think we would directly take it from the data lake. We wouldn't really store a copy of it on our end. So the data remains in the data lake. So we would pull that out, train, and then the model is exported. So we wouldn't retain any of that data on our side. So the data still remains in the data lake that's managed by AMCOP.
I hope they have all got the answer. Okay. The next one is, have you implemented any NWDAF use case? I think Sandeep, it's for you.
Hello?
Yeah, Sandeep. So
yeah. So this is for me. Yeah. So we have. So recently we developed this NWDAF for the NF load use case, and so it can predict the CPU load of the target applications. So that is what. Yeah, that is something that we have.
Okay. Can there be multiple NWDAFs?
Yes, there can be multiple. So these are network functions, 5GC network functions, and there can be multiple of them addressing specific use cases, and they are all differentiated through the analytics ID that they possess.
Okay, thank you. Any more question?
There were a bunch of questions on the chat, so let me just respond just so for the benefit of others.
Yeah.
And also be interested in the same questions. So one of them is, so I'll not read all of them, but at least some of them, which may be of general interest. So what is the data source for NWDAF? And I think Sandeep's presentation mentioned it, that the source could be any of the network functions or OA in case of NWDAF. So another question is, are apps also built by you, or is there a marketplace? So at the moment, we don't have any RApps. We do plan to build them over time, but we also plan to partner with other vendors or any other open source initiatives. So that's our plan. And what else? Is the AI model training done on NWDAF or SMO? And the answer is no, it's done outside. So in fact, the Predera platform is where is what we have shown as one of the possibilities where the model training is done. So those were some questions that came in the chat.
Yeah. Shriram, any more questions that you want to say, or like there were a bunch of questions actually when I'm seeing that.
Yeah, so I think most of them I responded directly to the Hari and Jane had questions. I answered them, and I read out some of them. So I did not read all of them, but I read out some of the answers.
Yeah. So thank you so much. Please do let me know if you have any queries. And as I already informed all of you, I am recording the session, so we will be sending, on request for sure. So thank you so much, Vamsi, Sandeep, and Shriram for the knowledge sharing session we had today. And let's catch up next on 9th August with NWDAF with NF load cases, implementation, design, and orchestration. It's going to be a very interesting one. For any questions on this webinar, please reach out to me, priyasi@aarnanetworks.com or info@aarnanetworks.com. And all of you have my email IDs on the meetup channel. Let's catch up on 9th August. Thank you so much for everyone joining. Good day and good night. Thank you so much.
Thank you.
Yeah.
Thank you, everyone.
Thank you.
Okay, bye.